Hi, welcome to Wise Guys. This session is for molecular formula of a compound. Molecular formula of a compound actually is the actual formula. So, for example, the empirical formula of glucose is CH2O. The molecular formula or the actual formula of glucose is C6H12O6. So looking for the molecular formula of a compound, we can follow the following steps. First step is to find the empirical formula of this compound. The second step, to find the molecular formula. So that's why when you're looking for molecular formula, you always need to first find the empirical formula. After finding the empirical formula, you calculate the molar mass of the empirical formula. Because when you looking for molecular formula, and you're not only given the percentage composition of this compound, also you're given the molar mass of this compound. That's why you already know the molar mass of this compound. After you find the molar mass of the empirical formula, after you find the formula, you calculate the molar mass from the empirical formula, you divide it, then you got the number of multiples. After you got the number of multiples, then you just multiply the number of multiples to the simplest or to the empirical formula to get molecular formula. For example, in this case, you first find the empirical formula of this glucose is CH2O, and then because you already have the molar mass of this compound, with the molar mass of the compound is calculated from this one you're given. This molar mass is talking about this molar mass. So because as we know from empirical formula to molecular formula, you multiply by 6. In this case, you multiply by 6, and actually the 6 is number of multiples. So actually, to looking for the molecular formula, after you find the simplest form or the empirical formula by using the percentage composition, and then you can find the molar mass for this empirical formula. And because you already have the molar mass of this part, that's where you can find this one, right? So actually we can write, this is molar mass, so is molar mass of for empirical. This is empirical, and this one times 6, right? For example, times 6, which is this example, but we use n number of multiples, and then equals to the molecular molar mass, which is for this is a molecular formula for mass, right? You got this. So because we, after find empirical formula, we can calculate the molar mass for empirical. Now, as we already given the molar mass then can divide it, which is the second step, molar mass of the compound divide the molar mass of the empirical, find the number of moles, right? And after this one, we multiply by number of moles to each simplest form ratio, and we got molecular formula. Let's look at the examples. This example is given 49.5 carbon, 5.15 of hydrogen or percent, and 28.9% nitrogen, and 16.5% of oxygen. This is by mass. Okay, that means in 100 grams, this is the mass of each element. The molar mass is 195 grams. This one, this information is the molar mass of, this is a molecular formula, right? So we need to find the molar mass. If we can find the molar mass from empirical formula. First find this one, then first find this one, then find n, number of multiples, and finally we can get this formula. Okay, so I set a table. I say this compound is CX, HY, and Z, and OW. The percentage composition is 49.5% of carbon, 5.15% of hydrogen, 28.9% of nitrogen, and 16.5% of oxygen. So in 100 grams, we have 49.5 grams carbon, 5.15 grams of hydrogen, and 28.9 grams of nitrogen, and 16.5 grams of oxygen. The molar mass for carbon is 12.01. This is grams per mole. Hydrogen is 1.008. Nitrogen is 14.01, and oxygen is 16.00. Okay? And after find this one, we can say the total, we have the number of moles. You need to divide it, the mass in 100 grams by the molar mass. So 49.5 grams divided 12.01, we got 4.122. We still keep 4 sig figures. And 5.15, this is actually 0, right? Divided 1.008, we got 5.109. And this is 28.9 divided 14.01, we got 2.063. And 16.5 divided 16.00, we got 1.031. So when we do this one, we need to be careful. We cannot round too early, because we all need at least 4 or 5 sig figures. And then we got the whole number ratio. Same thing, we find the whole number ratio using this information, because you have this is the moles, find the whole number ratio. We divide the smallest number. This is 1.01031. If this is 1, divided 1.031, then this is equal to 1, right? This is equal to 1, and divided this one by 1.031, you almost get that this is 2, and divide this one by 1.031, you got the 5, and divide this one by 1.031, you got the 4. The whole number ratio of carbon to hydrogen to nitrogen to oxygen is 4 to 5 to 2 to 1. So this is already a whole number, because you can see this is very close. This is divided as 4.99 something, actually is 5. So that's why the empirical formula of this compound is C4H5N2O1, which is O. So after you find the empirical formula, then you can calculate the molar mass for empirical formula. So what is this one? You can calculate this one 4, multiply this one, because this is a molar mass for carbon. You 4 multiply 12.01, right? So we can write down this one. The step is we have this one equals to 4 multiply 12.01. I'm not put the unit, plus 5 multiply 1.008 plus 2 multiply 14.01 plus 1 multiply 16.00, and this is add together. You got the molar mass of the empirical formula, which will give us the total is 97.1 gram per mole. This from empirical. That's why we find this one. The molar mass of empirical formula is 97.1 gram per mole, and the molar mass molecule formula is 195. This is 195 gram per mole. Okay, then we can figure out the number of multiples. So the number of multiples is using 190, the total molar mass of a compound, which is the 195 divided by the empirical is 97.1, which we got the 2. The 2 is number of multiples. So this one we find the number of multiples by dividing this number by that number. We got 2. So yeah, this is multiply 2 equal this. After you multiply 2, that means for each the ratio we need to multiply by 2 to get the molecule formula. So which is C8H10 and 4O2. So this is the molecule formula we're looking for. Okay, this is presented by Wise Guys. Thank you very much. Have a nice day.